Hello, I am Zara. And today, I'm gonna share with you my research on the pros and cons in building a Martian colony. Before we jump into the topic, we need to answer several questions and face many challenges. So, let's get started. Journey to Mars. NASA began our exploration of Mars more than 4 decades ago, when our robotic explorers were the first to study the red planet. Today, our orbiters and rovers have changed the way we look at Mars and continue to make important scientific discoveries that will one day pave the way for our astronauts. Aboard NASA's Orion spacecraft and Space Launch System rocket, astronauts will explore an asteroid in the next decade and return to Earth with samples. This experience will help us test new systems and capabilities needed to get to Mars. And right now, NASA is using the International Space Station to conduct cutting-edge research and technology development to help prepare our astronauts to take the next giant leap in exploration. Can we live on Mars? #Earth versus Mars. Have you ever imagined what would happen if all the human race outpaces the resources of our planet? Many people wonder if moving mankind to another planet is possible. Scientists agree that of all the other planets in our solar system, Mars would be the most habitable. But that's not saying much. If the goal is to create a self-sustaining Martian world, then life will be difficult and dangerous. They both have almost same axial tilt, so Mars will experience similar seasons. Mars' orbital eccentricity is much larger, so the length of the seasons varies, and a year almost lasts as twice as long on Earth. They both take almost the same time to rotate around their axis. So at Mars, we might still have an approximate of 24-hour clock. Both the planets are terrestrial planets. Hence, they both are made up of rock and metal. They both have same internal structure. They both have an inner core of metal, surrounded by a mantle of rock. A thin crust covers the mantle. The desert terrain of Mars is similar to some regions on Earth. They both have ice caps at their poles. Martian poles are made of water ice and frozen carbon dioxide. The cap grows in winter, in the southern part, as carbon dioxide from the atmosphere freezes. The cap shrinks again during the Martian summer. Despite these similarities, Mars differs with Earth in many ways, making it really challenging to turn it into a complete, inhabitable planet. Diameter of Mars is about 6,779 kilometers, just over half the width of Earth. Its volume is 15% of the Earth. The total surface area of the Mars is nearly as large as all of the land on the Earth. Earth's moving crust prevents the formation of very large volcanoes, whereas Mars' crust does not move, so very large volcanoes can build up. In fact, Mars has many active volcanoes, Olympus Mons being the largest in the entire solar system. The atmosphere of Mars is very thin, as compared to that of the Earth. The atmosphere of Mars is mostly made up of carbon dioxide, nitrogen and argon gases. Unlike Earth, there is no breathable air on Mars. Unlike Earth's thick atmosphere, the thin atmosphere of Mars does not provide any protection from the asteroids and comet impacts. Unlike Earth's thick atmosphere, the thin atmosphere of Mars does not allow sunlight to stay on Mars, it easily escapes the planet. This is the reason why the temperature on Mars ranges from 20 degrees Celsius to -153 degrees Celsius. So, if you were to stand on Mars at noon, it would feel like spring at your feet, 24 degrees Celsius, and winter at your head, 0 degrees Celsius. Earth has the most favorable temperature because it lies in the Goldilocks zone, which means habitable zone, where the temperature is just right not too hot, not too cold, for the liquid water to exist on the planet, making existence of life on Earth possible, unlike Mars, which is not only known as the Red Planet, because of rusty iron in the ground, but also known as the Cold Desert, because it is extremely cold, dry, sandy, and dusty. The air pressure on Mars is very low, as compared to that on the Earth. The gravity on Mars is very low, as compared to that on the Earth. This can impose prolonged settlement problems. The soil on Mars is very toxic, and radiations from the sun is deadly, making it riskier to plan a human settlement on Mars. How to get to Mars? #entering the red planet. What do we need in order to get on Mars? Number 1, we need a rocket to escape Earth's gravitational pull. The heavier the spacecraft, the powerful your rocket needs to be to lift off. Secondly, we need to be sure that we launch the rocket at the right time. Mars and Earth orbit the Sun at different speeds and distances. Sometimes they go really far apart, other times they come really closer together. In every 2 years, the two planets are in perfect position to get to Mars with the least amount of rocket fuel. That's important. The total trip is over 300 million miles. Finally, we need to make sure that the aim is right. We can't shoot for where Mars is at launch time. We have to aim for where it will be when we get there. It's a lot like how a tennis player hits the ball, and the other player runs towards it to receive it and hit the ball back. We will also have to correct the direction along the way so we don't miss Mars. If everything goes well, then we can get to the red planet in 7 to 8 months. Then landing on Mars will be a whole other challenge. Landing on Mars. #safely. The spacecraft hurtles towards the planet at thousands of miles per hour, so we got to hit the brakes in a hurry. Since there is hardly any drag friction in space, as space is extremely vacuum, it is difficult to slow down the space, even if you apply brakes to your spacecraft. First, the delicate probes need to be protected in heat shield. This heat shield will protect the spacecraft inside for entry into the Martian atmosphere. Once past the high temperatures of atmospheric entry, use a parachute to slow down even more. Still falling at over 100 miles per hour, we need the right system to land safely. Here are some options. Option 1. For small to mid-size rover, use a cushion of airbags, along with retro rockets. Impact at 30 miles per hour, and bounce to a stop. Option 2. With a large lander, use retro rockets and landing legs to touch down, going about 6 miles per hour. Option 3. With a large, heavy rover, use a big jetpack to slow down to under 2 miles per hour. Then gently lower it on cables to land on its wheels. However we choose to do it, it will require a lot of skills, as landing on Mars is not that easy. List of problems, and their respective solutions, to build a Martian colony, #settlement on Mars. According to the scientists, the best place to build first colony on Mars would be near its equator, under the hidden chambers, located under an area called the Hellas Planitia. This would help protect astronauts from huge swings in temperature and damaging radiation that they would be exposed to on the Martian surface. For electricity on Mars, we can use solar energy during the day. And for nighttime, we need to build battery storage to keep the Martian colony running efficiently. When we grow crops on Mars, we can use agricultural wastes as biomass fuels for transportation. Initially, the first crew to land on Mars needs to bring their own food from Earth that would last for a year. Meanwhile, they can also grow food using their body wastes, like urine and stool. The toxicity of the Martian soil can be reduced or eliminated by leaching out the perchlorates from the soil and separating out the water. The primary source of water on Mars will be regolith. Regolith is the layer of loose, solid material covering the bedrock of the planet. Initially, the first Martian crew needs to carry a good supply of water from Earth until they start extracting the Martian water. Mars has water in its poles as ice caps that needs to be liquefied using some heating system. We can also extract some of the water from Martian atmosphere. Mars has literally no breathable air for humans to survive. But Mars do have a lot of oxygen in the form of compounds like carbon dioxide in its atmosphere and water in its ice caps in its polar regions, which is trapped in the form of ice. We need to separate this oxygen from carbon dioxide using electrolysis method. But that would need a lot of energy resource. So, initially, the first Martian crew needs to build a technology to electrolyte all the Martian carbon dioxide, collect and store enough oxygen for 2 years to meet the oxygen needs of the entire colony. All communication between Mars and Earth goes through satellites. Because of the distance, there is a substantial delay. As communication signals travel at the speed of light, this means that it can take between 3 and 22 minutes for the information to reach the other end, so a phone call would not be practical. Strong antenna signal connections between the satellites orbiting around the Mars and the landed rovers can establish successful communication between Mars and Earth. Initially, first Martian crew will need a rocket launching station for interplanetary transportation. We will also need cars, tractors, and road rollers for intercolony transportation and to build the colony. These vehicles can work on solar energy. We can also use agricultural wastes to create biomass that would be converted into liquid fuel for our vehicles. Luckily, the planet provides a few raw material to make concrete, to build roads and houses. Mars is a home to several large caves that would screen settlers from deadly radiations. Since the air pressure on Mars is very low, we will need smart, pressurized heating systems to maintain the air pressure. Since the gravity is very low on Mars, it can be deadly for our internal organs. Hence, we will have to resolve this issue by doing a lot of workout until rotators are built. Martians can use a democratic government where everyone gets equal right to speech and express their views and share their ideas. We can do most of the indoor activities that people do on Earth. For example, reading, playing games, writing, painting, working out in the gym, and watching TV, listening to music and doing parties. Since Mars has no resources, and the atmosphere is so harsh on humans, the astronauts will have to stay indoors to protect themselves. They will get homesick. So, in order to keep them away from homesickness, the astronauts have to be highly entertained, and there should be a tracker to keep a check on their mental health.